Alrighty, well today we are going to add mixed numbers. Add mixed numbers. Let's look at this model real quick right here. What addition problem does this represent? Well, here we have 1 whole, and we're adding that to 1 whole and 3/4. So this is the addition problem represented by this model. If I wanted to use a number line, we use a number line much differently than we do when we have problems set up like this. We use it very differently. Just like how we used a ruler, we used the whole numbers first, and then we took care of the fractions. That's not what we'll be doing down here. But for a number line, let's do this. So we start at 0 and we go to 1 whole. That's my 1, my positive 1. Then I see I have another whole here. So that's another whole. And then I'm going to break this one up into 3/4. And I'm going to go to 1, 2, 3/4 of those. So I see my answer, I would end up at 2 3/4 on my number line when I added these numbers. Now, if I was not using a number line, I would follow slightly different steps. And here are those steps. Step 1, find a common denominator. Find a common denominator. Then, unlike what we did here, we're going to add the fractions or the fraction pieces. Add fractions. And then we're going to add the whole numbers. So let's set our problem up. Sometimes you can keep it like this. It's all preference. And some people prefer to write it this way. This way will come in handy. Oops, that should be a 1. This way would come in handy when we get to our subtracting because it's easier to see this way. Before we can add these fractions, we need to have a common denominator. Well, let's look at just changing this fraction here. Let's change our 1/5 to have a common denominator, having the same denominator as that 1/2. Well, let's see. 5 can multiply to be 5, 10, 15, 20, and so on. 2 can multiply to be 2, 4, 6, 8, 10, so on. I see that they can both multiply to be 10, so 10 is going to be my goal. 10 is going to be my goal. 5 times what gives me 10? Well, 5 times 2. Since I don't want to change the value of this fraction, I need to multiply by a giant 1. And to do that, the denominator and numerator need to be the same number. So 2 divided by 2 gives me 1. I won't be changing the value. 1 times 2 gives me 2. Here, 2 times what gives me 10? Well, 2 times 5 is 10. I need to multiply by a giant 1 so that I don't change the value of my fraction. That means our numerator and denominator need to be the same because 5 divided by 5 is 1. We're just going to change how the fraction looks, not the value of the fraction. 1 times 5 gives us 5. So now I'm going to rewrite my problem with a common denominator, 2 2/10 plus 1. Notice how I'm writing the same whole numbers down, 1 5/10. Let's do this addition. 2/10 plus 5/10 gives us 7/10. 2 plus 1 gives me 3. I found a common denominator. I rewrote it in my problem. Then I added the fractions and got 7/10. Then I added the whole numbers and got 3 as my whole number. And this is my final answer. Just like if I were to add, let's say, 22 plus 17, I would start here first, and then I would add this. right? So we do the same thing with our fractions. We add those first before we add our whole numbers. Let's go ahead and rewrite this vertically so that we can solve it. 2 4/5 plus 1 1/2. As of right now, I cannot add those fractions, so I'm going to have to find a common denominator. So I want to change, just the fraction piece is fine. I'm going to change that 4/5. I'm going to change that 1/2. I'm going to change that 4/5 and going to change that 1/2. So 4/5. Let's see, we already decided that 5 and 2 can have a common denominator of 10. So let's use 10 again. 5 times 2 over 2. So because 5 times 2 is 10, so I'm going to do 4 times 2, which is 8. 8/10 and 4/5 are the same value of a fraction. Here 2 times 5 is 10. 1 times 5 is 5. 5/10 and 1/2 have the same value. So now I'm going to rewrite this as 2 8/10 plus 1 5/10. Well, 8/10 plus 5/10, that gives me 13/10. Oh no, what do? I have an improper fraction. Well, this improper fraction can be rewritten. Let's go ahead and see. 13 divided by 10. I can make one whole group of 10 with a remainder of 3, and I'm still dividing that 3 by 10. So this is the same as 1 3/10. Well, I'm going to use it just like I would in a normal problem where I regroup. Here, I'm going to write down those 3/10, and I'm going to carry over that one whole. Carry over that one whole. So here I'm writing that fraction piece, and I'm carrying over that one whole. Just like if we would have added 36 plus 17, you would have gotten 13, and you would carry that 10, right? So just like that, we're doing that here. So we added our fractions, now we're going to add our whole numbers, and we get 4 3/10 is our final answer. This one gets a little bit more complicated. So we went and we found common denominators. 4/5 is 8/10, 1/2 is 5/10. We added those together, and they added up to more than one whole. So I changed them to a mixed number, so that way I would know what my fraction piece would be and what my whole number piece would be, and I carried it over. Then I added my whole numbers, and I got 4. Let's continue on to the bottom. Catherine went hiking on the pond trail, which is 3 5/8 miles long. The willow trail is 1 3/4 miles long, and the birch trail, which is 2 1/2 miles long. Which expression shows how many miles Catherine hiked? Well, here I don't see a final answer. So which one could we use that's similar to these that would give me the same exact answer? Think about it and ask yourself why. Why is that one equal to how many miles she hiked? Does it matter that our whole numbers are separated from our fraction pieces? No, just like up here, we were able to add those fraction pieces and whole numbers separately, because I happen to know that 1 3/4 is the same as 1 whole plus 3/4. So we can break these down on the bottom similarly. Okay, so I'm looking and I see 3, 1, and 2. 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2. Okay, so the whole numbers are not going to help us. So let's look at the fraction pieces. Here we have 9/14, which I'm not sure, but maybe that's what they add up to be. Here we have 9/8, 5/8, 3/8, 1/8, 5/8, 6/8, 4/8. Whew, this is going to be hard. I suggest that we find our equivalent fractions to 1/2, 3/4, and 5/8 that have common denominators. Let's look at this as if we're actually solving it ourselves and see what we get. So I'm going to take that 1/2. I'm going to write 5/8 first just because it shows up first. 5/8, 3/4, and 1/2. I multiply by that giant 1, multiply by that giant 1, multiply by that giant 1, and I want a common denominator. What is my goal for a common denominator? Let's see, I know 8 can multiply to be 8, 4 can multiply to be 8, 2 can multiply to be 8, and let's show it here. 6, 8, 4, 4, 8, 8, 8. So 8 is going to be my common denominator. Could I use 14? Well, 2 can multiply to be 14, but 4 cannot multiply by a whole number to be 14, and 8 cannot multiply by a whole number to be 14. So A is already out. A is already out. So here, this one, 8 times what is 8? Well, that makes it easy. 1/1 is what I'm going to use here, and that fraction does not change. 4 times 2 is 8, so I'm going to multiply my numerator by that as well. 3 times 2 gives me 6. 2 times 4 is 8. Multiply my numerator by that as well. 1 times 4 is 4. So, which of these matches this? Let's see. 9/8. 5/8 plus 4/8 gives me 9/8. So B cannot be it. Which of these is correct? Let's see, 5/8, 5/8, 5/8, 6/8. Well, this one has that, and this one has it as well, that 4/8. What mistake did they make on C? What mistake did they make? Well, on C, they changed the denominator, but they did not change the numerators, which is a big problem, because these fractions don't have the same value as those fractions. So our correct answer here is D.